In this presentation, we are going to cover main topics as a research objective, understanding and framing the objective, what kind of data we are going to collect in the research, what is statistical measure we can apply on the data. While collecting the data, how the sampling framework should be, what kind of sample should be appropriate, what the error can occur due to the sampling, and mainly the sample size estimation problem. How much sample is appropriate for your research or your case studies. In this whole process, we are going to understand a few basic concept of hypothesis testing, the estimation problem, and type of errors and other statistical terminology. In the end of this presentation, I am going to conclude the learning which we gone through this presentation, and look forward to have a good session in understanding statistics. So in a whole research, what is the need of a statistician? Basically in clinical research. Actually, statistics is a multidisciplinary field. And nowadays, it's a very, very essential component in every kind of research in any domain. So pharmaceutical industry is also one of the component in research in that. Why we need a statistician and what statistician can help in whole research process? So let's understand it through different blocks. In the research, first of all, why we are doing the research? Because we may want to gain some more knowledge. We are uncertain about some situation. We want to estimate something. There are many kind of things why we want to do the research. Uncertainty is one component, and this is a major component belongs to the statistical domain. When there is any kind of uncertainty, a statistician has some kind of methodology to measure that amount of uncertainty. And once we are able to measure the amount of uncertainty, the reciprocal of that is certain. So we can also be certain about some finding. How much? We can estimate it. The second type of process is to measure the amount, magnitude. So it's come under estimation. We want to measure certain things, either it is prevalence, percentage, height, weight, or any kind of parameter. We want to measure. There also we need the help of statistics to summarize that. Sometimes we want to measure the risk, go-no-go decision, what kind of merit, demerit in terms of absolute risk or absolute benefit we have. This also can be taken care of to some extent with the statistical methodology. Once we have data, how to present the data, summarizing, concluding the observation, because you have a very bulk amount of data. But data alone is not going to tell something until you will be able to extract the message out from the data. And how to extract the message? Summarizing the data, understanding the core concept, finding out its central value, its kernel. All those things can be achieved through statistics. And then also, once we understand the summary, we understand the data, its pattern, we understand the risk, benefit, we estimated the magnitude. We also know that how much amount of uncertainty in our statement. This will enable us in decision-making process. And finally, we have to take the decision and move ahead. So from here I will start, and I would like to proceed with framing of the research objective. So what we do, what kind of research objective we should have. I would like to categorize it in 4 different or 5 different heads. Actually, some may be overlapping to each other, but broadly we can try to figure it out. That I want to discover something which is unknown, truly unknown. No one knows about this. And then I want to know what it is. This is one kind of problem. I can take it as a research objective and will proceed. Second type of situation is that we know something about that, but we are not sure whether my knowledge about this is correct or wrong. So this also can be validated with one kind of research objective. Similar kind of things about to prove and validate the knowledge which we have. So we know and we are certain also about that knowledge, but we want to revalidate it. Maybe in a different setup, maybe in a different population, or maybe in a different environment. So to validate the established knowledge in a different setup, we also can conduct a research. We may have frame our objective with that way. There are another situation that we know little about. We are also sure about our knowledge, but we don't know the complete picture. So we want to take it to the further level and we want to make the picture complete. So that way also a research problem can go. And there are a very typical and kind of a very abstract way of problem. Like I have my own story about this, about something. You have your own story about the same thing, and Mr. X may have a different story about the same thing. So many of us know many things about that thing, but actually what is the reality? We all may be correct with our own way of angle, and there may be a possibility we all may have a wrong. So with multiple version of story, multiple way, we want to know the actual reality. So this way also we can frame the objective. Now once we have framed the objective, our research may go further with three verticals. There are many other way, but I would like to classify it in a three different way of doing this. Once we don't know anything, we want to explore. Let's take it, go through the process, try to find out what knowledge we gain through the moving process. So we want to explore many of the things of that setup in my research. And this is the one aspect of exploring the thing. Statistical methodology, sample size estimation, all have a different aspect in this. I will cover in later slide. The second is, and kind of a bulk amount of task in research is to estimate the magnitude, the amount. So you may find out what is the average number, what are the prevalence, what is the percentage. All those is estimation problem. We want to estimate the magnitude. And the third thing is that we have some knowledge about that. And based on that, we have our own hypothesis about that. To test that hypothesis, whether I am correct or wrong, we want to conduct a research. So this is a third classification or third way of proceeding further. I have made certain assumptions, I have made certain hypotheses in my mind, and then I want to test whether my assumption is correct or not. So we will proceed accordingly with this. Now once we identify these three pillars, I would like to further take one by one, and we will discuss how to make a framework of your sample size problem with all three different classifications. Before proceeding to that, I would like to walk through with you all with some statistical definition which we encounter in our day-to-day life in reading the journals, going through the research, discussing in a forum. So I assume most of the terminology you are already aware. Just giving a brief light on that. So first, from where we start is universe, population, and sample. So this is kind of a set and subset process. Universe is the superset, the bigger set. And from that, there may be a different population. And then we are going to withdraw a sample from the population. Some type universe and population may be the same for your research problem, but sometime it may differ. So when we withdraw a sample, our sample should be representative of population. If it is a representative of universe, then your universe and population are same. But sometime it may be differ. It should be a true representative of population. If it is not true representative, there are some consequences. We will discuss later. Then objective, hypothesis, and parameter of interest. So based on your research objective, you have certain problem on which scale or on which parameter you are going to measure your objective. To achieve your objective, you are going to measure certain things. It may be a different scale, it may be a different way of assessing or measuring it. We will discuss later how to measure and what are the common things to measure. But on which you are going to measure your objective, that is your parameter of interest. And if you have certain assumptions about that parameter, you already build your hypothesis, then this will become your to hypothesis. There are two different hypotheses we are going to deal. I will come with that later. In your data, there is a concept of variability, probability, and confidence interval. So probability is also known the measurement of uncertainty. So when you are certain about your process, or when you are uncertain, probability is going to measure the amount of uncertainty based on the data or based on your observation. And this is the backbone pillar of the whole statistical theoretical development or practical aspect of the statistics. Because without this, it's difficult to have all the process and treatment in the statistics, which we do. So once you got some estimate, how much you are sure that if another person will do the same kind of research, he will come exactly same what you have. Maybe he come exactly same, or maybe he will have slight difference than you. So then you will construct a boundary around your estimate, that okay, if my estimate is X, then maybe plus minus some unit from X is the interval, and I am sure that any person will do experiment, he will fall in this boundary. How much sure? 90%, 95%, 100%. That will be your confidence interval. Hypothesis will be in two different types, null and alternate, as I told already above. Now, error in